Right, charging systems, like all systems on motor vehicles, have evolved, and now the ECU is an integral part of the charging system. Now, to test that effectively, we need to go beyond the basic tests, so we've introduced the use of an oscilloscope. This is a laptop-based unit that uses a device we've purchased. It's a picoscope, and we can actually look at 3 channels. We're going to be looking at the voltage coming out of the alternator, and that'll be on the green channel. Sorry, that'll be on the blue channel from the battery. We'll be looking at the current flow with a current clamp, and that'll be our red channel. And our green channel is the new wire that we're considering, and this is the wire that feeds back between the alternator and the ECU. And this is the ECU commanding the alternator to cope and to charge. We're going to start the vehicle, and then we're going to go through and show you the checks and why it's important to do these tests on computer-controlled charging systems. Our voltage is currently on the top blue line here. It's just set at around about 12.5 volts because we've got a fully charged battery. We've got no current, we've got no feedback signal. We start the engine, and immediately our voltage rises up here, and it's around about 14.8 volts. Notice this red line. That's our rectified AC. That's actually the DC voltage we're using, but it's not smooth because that's the top of all the small waves. And directly below it is this square wave signal. That's the computer feedback signal. And we're able to see that if we turn the lights on, for example, even at idle, and the cooling fan as well, this pattern changes. If I just stop it for a moment, we're going to see that we've got the alternator really turned on flat out along here, and we see the current going up a little bit. Then as the pulses get a little bit less, so the output goes down a little bit. This is the computer helping the vehicle cope with a high load at very low speeds to try to keep the alternator charging so we don't have flat batteries running around the city. We start the vehicle again, and if we can just turn the headlights on again, and the load, I'll just get them tracking again, we're away. Our output, we can read over here, we can read off our oscilloscope as about 50 amps at the moment, and that's measured by our current clamp. So we're using an oscilloscope to show us the voltage, the current, and the feedback signal essential between the alternator and the charging system. And in this way, we're thoroughly examining the charging system on this vehicle. One of the additional parts for checking a charging system these days is to look within the ECU at the active data. Here we've connected up a scan tool to the diagnostic connector inside the vehicle, and that's our standard OBD2 connector. And these connectors are standard across a range of trades. So your trucks will have them, your cars have got them, 4-wheel drives, and some motorcycles. So this isn't an exclusive process, this is something now that we're doing more and more. We've brought up on this vehicle the 3 key pieces of information we need. We need to know the battery voltage, we need to know the engine speed, and we've got what Hyundai call the relative charge value. And this is the percentage of on and off time and the signal coming from the ECU to the alternator. So let's have a look at this active data and see what it can tell us. Other manufacturers will give you a lot more data. This is all about you researching your own vehicles to know what you're looking for. So we'll start the engine. And immediately I can see that at my battery, I've got about 14.3 to 14.4 volts. My engine's idling at 850 revs. And I've got a percentage on time of 33.8%. Now, I can also see this information as a graph. So, on this particular scan tool, I've got it quite clearly, a little bit like our oscilloscope previously. So if we turn on the headlights and some loaded idle, my percentage time has moved to now about 50%. The idle has dropped fractionally as the engine starts to compensate, and my voltage has come down to 14 volts. So if we bring the engine speed up, my graph responds, and my relative on time will change now because the alternator is more capable of putting a higher output producing this load. So in this way, we can use a scan tool as well, not just to read fault codes, but to look at the data that the vehicle's working on to confirm that the alternator is being commanded by the ECU. So we can see that the charging system now is just an integrated part of the vehicle control system. And so with the aid of oscilloscopes and with scan tools, we can more accurately test our charging system on our vehicles that we see today. This technology isn't new, it's been with us for at least the last 15 years. So it's something to get on board with and be comfortable with using your scan tool and operating in your vehicles. Okay.